So for section 10.1, we're going to do a quick function notation review. We're going to be simplifying polynomials using function notation, which you guys learned about in Unit 5 last semester. So for our first example, let's look at f of x equals x squared plus 1 and g of x equals 3x plus 5. Let's say that I asked you to find f minus g of negative 3. And if you remember correctly, this is telling you two things. It's telling you, one, you're going to be subtracting, and two, you're going to be plugging that negative 3 in. So in essence, what we're really doing is f of negative 3 minus g of negative 3. We're plugging the negative 3 in and then subtracting. If I plug a negative 3 into f, I get 10. If I plug a negative 3 into 9, I get negative 4. Or a 10 minus a negative 4, which becomes a plus, and I get a 14 as my answer. And that would be my simplified answer. Let's take a look at a different one. What if I say I want f divided by g of 0? Well, remember, it's telling us two things. One, it's telling us we're going to divide, and it's telling us we're going to plug in a 0. So basically, this is f of 0 divided by g of 0. And if I plug a 0 into f, I get a 1. If I plug a 0 into g, I get a 5, making 1/5 my final reduced simplified answer. Now I want to look at a little bit more complicated problem. Let's go ahead and say that f of x is 8x minus 9. And let's say g of x is the square root of 2x minus 1. And let's say that I asked you to find f plus g of x. Well, once again, it's telling us two things. It's telling us we're going to add, and this is telling us we're not actually going to plug anything in for x. We're just going to keep it as it is. So in other words, we're going to take f of x, which is 8x minus 9, plus g of x, which is the square root of 2x minus 1. Now, if we remember correctly from our last unit, when we add two square roots, you just put together like terms. So actually the 8x plus 9, the 8x minus 9 would stay out to the side, and then the 2x minus 1 irrational would stay over here. This would be our simplified answer. I know this looks funny, but we can't put anything together with that root since it's under a root. Now, since we have an x as part of our answer, we have got to determine what our domain is. Remember, domain is what I can plug in for x. And since this x is under a square root, it's kind of a little bit of a red flag. We know that we can't have a negative number under a square root. So for this 8x plus 9, I can plug in anything for x. It doesn't matter whether it's positive, negative, fraction. It doesn't matter. But for the square root, for the x under the square root, it does matter. So I'm going to come over here to the side. What's under the square root is the 2x minus 1, and I know that that has to be greater than or equal to 0. In other words, it can't be negative. We cannot have a negative under a square root. So I need to make sure when I add over that 1 and then divide by 2, I need to make sure that my x is greater than or equal to 1/2. That is my domain. In other words, if I have an x that's less than 1/2, what it's going to do is it's going to create a negative number under this square root. We can't have negative numbers under a square root. Otherwise, we jump into the imaginary or complex number system. For your final problem, I want to remind you of composition of functions. So let's say f of x equals 4x plus 1. And let's say g of x equals 2x squared plus 5x. And let's say what I want you to find is g of f of x. So this is a composition. This little O right here means composition. What it means, if you remember from Unit 5, you take the innermost thing first. So in this case, we're going to take the f of x first. Well, what is f of x? F of x is 4x plus 1. So I'm literally going to replace that f of x with 4x plus 1. And what it means then is take that 4x plus 1 and actually plug it into g. So I'm going to come up here in g and take each one of these x's out and replace it with a 4x minus 1. So instead of x squared, it's 4x plus 1 squared. Instead of 5 times x, it's 5 times 4x plus 1. Now, when I square this, I cannot just distribute that 2 in. I have to actually write it twice, like this, and multiply it out the long way. So what I end up with is 2 times 16x squared plus 8x plus 1. Now I'm going to distribute my 2 in. And distribute my 5 in. So I did both of those at the same time. And then we're just going to put our like terms together, which is going to get us 32x squared plus 36x plus 7. Now, what's my domain for this? Well, since there's no fraction and no square root, my domain is actually all real numbers. In other words, I could plug anything into this function and get an answer. There's no fraction restricting me from zeros in the bottom. There's no square roots restricting me from negatives. So I'm okay plugging anything into this function.